Yes, I'm Ernest, and this is Ernest Sciences and Mathematics TV channel. Before you proceed, I'd like to thank our members for engaging us in the comment section, and also request those who have not subscribed to do so, and also check that description box of various uploads. I'm going to put a link of similar videos which are going to be assisting us, of course, have a wider picture of the topic under discussion. In this particular discussion, I'm going to look at the group 4 elements. And these are groups of elements consisting of carbon, silicon, germanium, tin, lead, and ferrovium. And of course, we are going to limit ourselves to the discussion of the first 5 members. And that is going to give us a concept of how these specific members are going to react and be displaying a wide range of properties, especially in their chemical and physical characteristics. And this, of course, is going to be done using a discussion of the individual members. Now, the members of this specific group are going to be giving dramatically or very dramatically in a way that we're going to look at each member said, and of course that is going to assist us distinguish the members and give us some of the similarities which, of course, has given them the aspect of being classified as a group 4 element. Now, in our discussion, we're going to see that there is going to be a specific kind of characteristics, especially in the concept of bonding, whereby a member of, like carbon is going to be bonding covalently to form other compounds using the various kind of hybridization, which we have discussed in some of our videos. Now, some members, of course, as well as I've said, apart from bonding, they're going to display some kind of some specific forms, which we're going to refer to as isotopes. Now, there are going to be some forms, stable forms of the compounds of these particular members. And of course, we're going to see that some of them are going to have the ability to form chains, which we are going to refer to as catenation. This is going to be specifically the case for the members of carbon and silicon. And as we're going to see from this specific classification, which I've given in terms of color codes, carbon is going to be a member of the non-metallic group, which I've given in this particular case. But for silicon and germanium, these are going to be metalloids that are going to display both a metallic and non-metallic character in that specific case. Now, for tin and lead, these are going to be metallic members of the group. And therefore, we're going to see that the metallic character is going to increase down the group, as we're going to be witnessing from this specific rough display. Now, in my next illustration, I'm going to look at a few common characteristics of this specific member, perhaps in terms of electronegativity, melting and boiling point. And as I said, these members are going to display a wide range of characteristics, and therefore it's going to be easier for us to look at them at an individual level. Now, the general display that I've given on the board is a section of the group 4 elements. And these are the members of carbon, silicon, germanium, tin, and lead. And these are the electronic configuration. Of course, we have classified these members as the p block elements, which are going to be having this valency configuration, which we have just given in terms of S and P. And of course, that is going to be assisting us try to identify some of their diverse characteristics which are mentioned. Now, in terms of electronegativity, as I said, of course, there's going to be varying trends which are not going to be somehow having a specific trend. And of course, that is going to be essential for us in trying to look at the members at an individual level and try to see what are some of their characteristics. In this particular case, the melting and boiling points of these particular members are going to decrease in that specific order. And this, of course, is due to the fact that there's going to be an increase in their energy levels as we go down the group, as we had mentioned, just like the case for other members of different groups, for especially group 1, 2, and 3, which we have done in our previous discussion. Now, I've mentioned that these members are going to be displaying different properties, of course, which are going to be unique to each and every member of the group. And as I've mentioned, of course, the element of carbon is going to be bonding covalently to form compounds, and this is going to be especially the case for the different organic compounds which we have looked at in our individual videos. We have seen how these covalent members, of course, covalent bonds are going to be shown out, especially if I give the case of formation of methane, which is a carbon bonded to 4 electrons. This is going to be a covalently bonded kind of a molecule, and we have said that this is going to be giving the sp3 hybridization or sp3 hybridized molecule given as such. Now there's similar characteristics which is going to be witnessed, especially for the halide members of this specific group, and therefore we are going to have members of this specific group like silicon bonding with the fluorine to form this specific compound, and of course similarly we are going to have germanium bonding with the fluorine, and we can give other examples of tin bonding with the chlorine. And then lastly, of course, but not least, we are going to have a lead bonding with the chlorine given as such. So these are going to be similar kind of hybridization which we have mentioned, which are going to be basically the sp3 hybridized kind of bonding or covalent molecules, covalently bonded molecules, which are going to be witnessed as such. Now, of essence for us, we're also going to look at some of their characteristics, but we are going to, in this particular discussion, limit ourselves to a comparison between carbon and silicon, which are going to give us a specific general case for, or just a general case for the different members which we are going to come across. And the two elements are going to find wide application, especially in the organic, the applications which are going to depend on organic compounds and some of the industry, like the semiconductor, of course, devices. And I mentioned, of course, from our previous discussion in a statement, of course, in this particular discussion in a previous statement, that silicon is a semiconductor, and therefore it's going to find wide application in manufacture of semiconductor devices. So in this particular case, I look at carbon and contrast it with the silicon, and try to see some of the differences between the two members of this specific group. Now, carbon is going to have two principal isotopes. So I mentioned the concept of isotopes. So therefore, it is going to have two principal isotopes of diamond and graphite. And these are going to be members of this carbon, which are going to be appearing in terms of isotope. Now, this is going to have one stable diamond type crystalline modification, and therefore that's going to be in terms of one crystalline. So that's going to be one stable crystalline modification. So this is going to be having a crystalline modification of diamond. If I may give it in terms of a summary form given as such. So this is going to be one of the contrasting characteristic of a silicon and of course a carbon. And this specific of course form is going to be a stable one, and therefore that's going to create a contrast between the two. Now this is going to form two stable gaseous oxides. So in terms of oxides, so these are going to be two stable oxides. Now in our study of the carbon and its compounds, of course, I've mentioned about this one. So these are going to be carbon 4 oxide and carbon 2 oxide being given in that specific respect. Now this is going to form one oxide that is going to be stable at room temperature. And of course, this is going to be the silicon oxide given as such, and this is going to be one oxide that is stable at room temperature. So I'm going to give you this one in terms of a statement or summary form because of our space, and that is going to assist us try to contrast the two. So this one is insoluble in alkaline media, and the second one reacts with alkaline media to form hydrogen gas and a silicate. So this is going to form hydrogen gas and a silicate. So this is going to contrast between the two members of the silicon and the carbon in terms of the reaction with alkaline media, and therefore that's going to form the difference between the two. So this is going to form the principal oxo anion of the carbonate, the principal oxo anion of the carbonate given as O subscript 3 2 negative for charge, and then we are going to have this one from the principal oxo anion. So this is going to be the silicon oxide given as such one, and of course this is going to form the difference between the formation of oxo anions of the two. So this is going to be having what we call a catenation, which is a strong ability to form chains, while this one is going to be having less tendency of a catenation, and the chains of so let me give this one in this specific form. So this is going to have a limitation of only six atoms bonded together to form a chain, and that of course is going to contrast it with this specific member of carbon, which is going to have a strong ability for catenation, being shown as that one. So the rest perhaps I can just mention because of our space, which is going to assist us of course understand the difference between various characteristics just for a limited number. So there is going to be another wide range of characteristics which we are going to witness, which are going to be different for the two members of the group. So this one is going to readily form multiple bonds by the use of sp2 plus p hybridization, which we had said, and sp and plus p2 orbitals. And this is going to have a less tendencies for catenation, as we had said, and of course that's going to be limited to 6 atoms of a silicon given as that. And we're going to look at the bond energies in a different discussion, and that's going to also assist us differentiate between the two. But in this particular case, this is going to be the summary of some of the characteristics of a group, of course, 4 elements. And of course, we're going to look at in some of the applications, some of the additional characteristics which we are going to maybe be experiencing as we go by. So that is it for now, guys. Bye, God bless you. Catch us in our next video.